Welcome to The Explainer. Today, we are putting together the ultimate guide for running your very own powerful private AI. Because, by 2026, the game has totally changed, and we're going to show you exactly how to get ahead of the curve. All right, let's get right into it. Here's our roadmap. We're going to start with a big why. Why even do this? Then we'll cover the absolute golden rule of hardware, pick out the best gear, check out the software the pros are using, and finally, see what happens when you push all this tech to its absolute breaking point. So this AI revolution is in full swing, right? And it really forces a huge strategic choice on everybody. Are you going to rent your AI from the cloud, or are you going to build it yourself? And this, right here, is the fundamental decision that every single organization, and frankly, every power user, is facing right now. This isn't just some tech choice. It's a major financial and strategic decision. It's really that classic trade-off, isn't it? On one side, you've got the cloud APIs. They're super convenient. You just pay as you go. But you're also handing your data over to someone else, and those costs can really stack up. On the other side, you can bring it all in-house. Sure, it's a big investment up front for the hardware, but you get total control. And more importantly, your data stays your data. And here's the kicker, the part that might really surprise you. For any company that's using AI a lot, that big upfront hardware cost can actually pay for itself in as little as 2 years. Yeah, 2 years. When you compare it to just renting from the cloud, it's a long-term play that can save you an incredible amount of money. Okay, let's get into the first principle of building your own AI rig. And I need you to forget everything you think you know about building a gaming PC, because in this world, it all comes down to one thing. Just one. And this quote just says it all perfectly. VRAM is king, and everything else is a compromise. See, your GPU's video memory isn't for pretty graphics anymore. It's for holding the AI's entire brain, all of its knowledge, what we call its weights, and its short-term memory of your conversation. VRAM is literally the most important currency you have. But hang on a second. How in the world do you fit a model with, say, 70 billion parameters, which should take up well over 100 gigabytes of memory, into a regular desktop computer? Well, the answer is this really clever trick called quantization. And this table, this is where the magic happens. By basically simplifying the numbers inside the model's brain, we can shrink it down like crazy. And look at that sweet spot, Q4_K_M. You get a massive 75% reduction in the memory it needs, but you only lose a tiny, almost unnoticeable amount of quality. It's become the absolute gold standard for running these huge models at home. Okay, so we've established VRAM is king. Now let's go shopping. What's the hardware in 2026 that's going to give you the most of it? Yeah, in 2026, the entire landscape has been redrawn, and it's all thanks to NVIDIA's Blackwell architecture and the new RTX 50 series. These GPUs, they're not just for gaming anymore. They were built from the ground up for the AI era, with huge boosts in VRAM and memory speed. Just look at the new flagship, the RTX 5090. This is not a small step up. We're talking 32 gigs of super fast GDDR7 VRAM, plus a nearly 80% jump in memory bandwidth. And what that actually means for you is you can run bigger, smarter models, and you get your answers back way, way faster. But hey, you do not have to spend $2,000 to get in on this. The RTX 5070 Ti is really the value champion for new builds, giving you a really solid 16 gigs of VRAM. And you know what? Don't sleep on the used market. A last-gen RTX 3090 is still an amazing choice because it has a massive 24 gigs of VRAM, which is actually more than a lot of brand new cards. All right, we've got the hardware sorted. Now let's talk software, because this is how the pros are squeezing every last drop of performance out of their rigs, even when they're using a weird mix of parts. So here's where things get really crazy. The serious power users, they're not just using one GPU. They're combining multiple cards, sometimes even from different generations. Like imagine running 2 brand new 5090s alongside 2 of your old 4090s. It's an incredibly powerful setup, but it creates a really complex software puzzle to solve. So how do you solve that puzzle? Well, you turn to some amazing open source tools. The go-to for pretty much everyone is a program called Llama CPP. But if you're running one of those funky mixed GPU setups and you want every ounce of speed, you use this special souped-up version called Llama CPP. And check this out. This number right here shows you just how powerful the right software is. Using that special version, one user hits 757 tokens per second just processing the prompt. To put that in perspective for you, that's like the AI reading an entire page of text in the blink of an eye. It's an insane level of performance, all unlocked by software. Okay, so we've got the monster hardware, we've got the specialized software. What happens when we try to run one of the biggest open source models ever released? And I mean a giant. We're talking about Meta's Llama 3.1, which has 405 billion parameters. This is a model so huge that just a little while ago, the idea of running it outside of a massive data center was basically a fantasy. But there's a catch, right? To get this beast running on your own machine, you have to quantize it. You have to squeeze it down pretty hard to fit into your VRAM. So the big question becomes, do you break it? Does the model lose its ability to think straight when you give it long, complicated documents? And the answer from the community, from the people who've actually been testing this, is crystal clear. A fairly gentle 6-bit quantization holds up incredibly well. But if you get too aggressive, if you push it down to 3-bit or even lower, the model's performance on long documents just completely falls off a cliff. It loses the plot, starts repeating itself. There's definitely a limit to how much you can shrink these giants before they start to break. So, we've been through the why, the what, and the how of it all. Let's bring everything together now into a really simple framework to help guide you on your own AI journey. It really does all come back to VRAM. Your path is basically decided by how much of it you have. So if you're starting out with 8 to 12 gigs, you're going to be playing with the smaller but still very capable 8 billion parameter models. 16 gigs, that's really the new sweet spot for some seriously powerful models. Once you jump up to 24 or 32 gigs, you are in the prosumer tier, running some serious AI. And of course, if you go multi-GPU with 48 gigs or more, well, that's when you get to run this 70 billion parameter behemoths. Just think about that for a second. The tools, the hardware, the actual models that used to be locked away inside massive data centers, they can now literally live on your desk. The age of powerful, personal, and totally private AI is officially here. So that just leaves us with one final and I think really exciting question. What will you build?